Hey everybody, welcome back to Mr. Anderson's Algebra 1 lessons. Today we're going to be talking about exponents. And so I want to do a little review with you guys on exponents. And so I'm not really going to go into some of the laws with exponents. I just want to do a couple of examples to show how to add or multiply the exponents together. What should you be looking for when you're trying to solve some of these problems? Looking at the base, looking at the exponent, looking at the power, things like that. And so I'm going to do a couple examples that are fairly simple, and then I'm going to take a look at some increasing the difficulty a little bit. Overall, we're going to take a look at about 4 examples. So I want to start off with let's do an easy one here. Let's take a look at this guy. We got 3x squared times 5x. And so what I'm looking to do here is several things. I want to think about combining my terms, and I want to make the simplest thing possible. And I'm also wanting to look at what do I do with the exponents. And so when I'm looking at this, I got 2 numbers here, and the thing I want to think about is, what is my base? I'm asking myself this question: what is my base when I look at these 2 things, and what is it asking me to do? Well, I'm seeing that it's asking me to multiply these 2 together. I see there's an exponent, so I need to be thinking about what base I have and what do I do with those exponents. And I remember this rule right here, where I multiply. If I have 2 bases that are the same, I can add the exponents. Well, I see in this question 2 bases that are the same, and that is the x here. Okay, so I'm thinking to myself, okay, the base is going to be x. Now, if I do that, I can add the exponents together, like it shows right here in this rule. B to the n times b to the m is equal to b to the n plus m. So that means I can add the exponents. Now on this one, don't forget there's an invisible 1 as that exponent. So when I add the 2 exponents together, I have 2 plus 1, and that gives me 3. Now the last part that I need to think about is, what do I do with these big numbers out here? Well, these are called constants, and I can multiply the 2 constants together. So in this case, I'd have 3 times 5, and that would give me 15. And so this is my answer, 15, x cubed. And that would be how you would handle something like that. Okay? Now, what if I saw an example that, I'm looking at my notes here to see which one I can do. What if I saw an example that looked like this? 4x times 2x squared times 3x to the 0 power. Okay? So I have this right there. And again, I'm asking myself, what do I see happening here? And I see that I have 3 x's that are the same, so that means that the x is going to be the base in my final answer. But there's something different that I see here. I see this guy over here, and he's looking kind of funny because he's got a 0 as an exponent. Well, if you have a 0 as an exponent, you can see that we can use this rule right here. It's called the 0 power rule. And I proved this yesterday in my class, but basically if you have any term to the 0 power, it's equal to 1. Okay? And we can go into that a little bit later. But if you have anything to the 0 power, that equals 1. So now what I can write is I can write 3 times x to the 0 power, that's 1, so this term becomes this. Okay? And then after I get there, I can take a look at this guy. So this now becomes something that we did up here. So I'm multiplying the same base. So I have the same base of x. And don't forget, there's a little and tiny invisible 1 right there. So I can bring that down. So I'm going to have x as my base, and 1 plus 2 is 3. And then with the big constant terms, I multiply. So I have 4 times 2, and that gives me 8. Okay, now I'm not finished. Okay, so I have 8 times x to the third power times 3 times 1. 3 times 1 is just 3, and since I have a constant term here and a constant term in front, I can multiply the like terms together. So 3 times 8 becomes 24, and the exponent carries over, and so I have 24x to the third power. Super duper chill. Okay, so those are 2 examples where they're really kind of basic multiplying examples together. What do I do with the exponents? What happens in this situation? Now I want to take a look at a bigger term for us, and so let's take a look at some example here. Okay, I'm going to move up my paper a little bit. So the next example, let's take a look at what we do on this guy. Let's do 3x to the fourth times 3x squared. Okay, so there's a couple things going on here. On this one, we are going to take a look at this rule. Power of a power. So that means I can multiply the exponents, and I see that right here. Now you might not see this, but there's a little invisible 1 right here, and so I would be able to multiply those 2 together. So 4 times 1, that's going to give me 4. That doesn't really affect much, but what does happen is the 4 does affect the 3, because remember what's happening is that I'm raising this to the power of it. And remember, exponents are repeated multiplication. So what this eventually turns into is 3x times 3x times 3x times 3x. Okay? That's really what that's going on with this guy. Okay? And so then I could just say that that's really what's happening in this example. So this, I'm really just repeated multiplying this together. So really I'm just going to do 3 to the fourth power. This is going to transfer down to that. Okay? So 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3, I believe, is 96. So this turns into 96x to the fourth. Okay? And then I can just bring this guy over here. 3x squared. And so now this turns into something that I did before. So I have to add the 2 exponents and multiply this across. Okay? So what happens is now my base is x, and my exponents is 4 plus 2, so that's 6. And then 96 times 3, 96 times 3 right here becomes, I'm typing in my calculator, 288 x to the sixth. Okay? 288 times x to the sixth. Now, I'm taking a look at my answer key, and I've noticed that something went wrong here. And this probably is a good chance for us to double check our work, because in the answer key It says it should be 243 x to the 6. So something might have went wrong here. So what do you guys think? Maybe I did the multiplication wrong. Maybe I did 3 times 3 times 3 times 3 wrong. 3 times 3 times 3 times 3 is 81, not 96. So this should be 81x to the 4th times 3x squared. 81 times 3 is 243, and then the x to the 4th and x to the 2nd gives you x to the 6th. So here's a word of advice. Make sure you double check your work before you go forward, okay? So make sure that this is the right way, not this way, okay? Sweet. And it's always a good bet to double check your work anyways, because you never know when things are going to go wrong. Let's do one final example in this guy before I leave you with this. I'm going to push that up. And let's take a look at this guy. X squared times 3x cubed to the 0 power. Now this one's kind of tricky because some of you are probably going to try to figure out what the heck this is. So we can do that. If you multiply those together, you got 3 times x to the 5th power with the 0 out there. So you have that. But if you remember, anything raised to the 0 power, that's just 1. So in actuality, if you realize that from the get-go by looking at this, you could have seen that this is just equal to 1. Okay, kind of a trick question. Anyways, that's been exponents, a little review. I hope you enjoyed. Please like, comment, subscribe. Hit me up for any more. Subscribe to my channel. I post weekly math videos. And if you would like to see anything else, please let me know so I can make a video for you. I hope you have a great day and keep on mathin'.